Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over similar figures. So we're first going to decide if we are given two shapes, are these two shapes similar or not? So the word similar, I want you to write down a definition here. Maybe, there we go, similar. So similar means that they're the exact same shape, however their size is different. So it's same shape, size is different, and what ends up happening is the side lengths in the shape are proportional. So we've talked a lot about proportions. Proportions mean two ratios that are the same. So in order to be similar, we want to know, are the side lengths proportional? Now, also, and we're going to get into talking about angles, but in similar figures, the angles are the exact same. Here we don't have angles. We're more looking at, are the side lengths proportional? So we want to make sure that we match up corresponding side lengths. So what that means is this top side length 4 inches, it matches up to the side length QR 2 inches. Those are pairs. Those are what we call corresponding. They're in the same position. Same thing then with the side length 12 and the side length 6. So what we will do is create a proportion with these. So the first ratio we could use is the LM, the first rectangle 4 inches, and we're comparing that to 2 inches. Now in the second ratio, we want to make sure, since on top the first rectangle's side length came on top, that means that the first rectangle on the other side length also has to go on top. So we want to put 12 inches on top in the second fraction on top, and then 6 on the bottom. So that way everything on the top is from the first rectangle, everything on the bottom is from the second rectangle, and then those corresponding sides match up. Now you could do this one of two ways. We could simplify 4 over 2. 4 divided by 2 is 2, and then simplify the second fraction. 12 divided by 6 is 2 as well. They're equal, so we know that these two rectangles are proportional. Now the other way, I also want you to write this down, because unfortunately not always do they simplify to perfect whole numbers like that. But remember the cross products. If we multiply the two diagonals, so one diagonal is 4 times 6, the other diagonal is 2 times 12, and those could go in any order. So 4 times 6 is 24, 2 times 12 is also 24, so that is a true statement. So we know that these two shapes, these two rectangles, are similar. And that's what we're answering. We're deciding if they are similar figures or not. I'm going to jump actually below to this third one. Now, again, we want to start out finding corresponding side lengths. So 3 kilometers matches up to 1 kilometer, and we could go ahead and write that ratio. So 3 to 1. Then the second side lengths are 5 and 2. So we will set up equals 5 over 2. So again, we could simplify those. I'm going to stick with the cross products, because eventually we're going to use cross products to solve for a missing side. So one of those diagonals is 3 times 2. The other diagonal is 1 times 5. 3 times 2 is 6. 1 times 5 is 5. Those two are not equal, so you often see it with that slash through the equal sign. So these two, and they're actually rhombi, 2 rhombi are not similar. Okay, and I'm going to leave these other two. I want you to pause and see if you can figure out, are these other two examples similar as well? And then we will do those together. So 1 over 5 is one of our ratios. Those two side lengths match up. And then the other pair is 2 and 10. Again, make sure that they are going in the same order. I put that first shape on top. This one goes on top, so it has to stay on top. 2 over 10 is its corresponding side length. So cross products, 2 times 5, 1 times 10. Again, it doesn't matter which one comes first, but 10 does equal 10. So these two, they are actually pentagons, are similar. And in class, we'll talk about how to actually write that they are similar. Now, be careful here. We want to make sure our side lengths match up. So the 5 actually matches to the 25. Notice sometimes shapes turn and they aren't always sitting perfectly next to each other. 2 matches up to 10. So we will put, again, the first triangle on top, and then we will use our cross products to determine, are they equal to each other? So 5 times 10, 2 times 25, 50 does equal 50, 2 times 25. So these two triangles are also similar. So they are similar. So what we did in those 4 examples was just decide, are their side lengths proportional? Are they similar or not? Now these next examples, we are actually told that they are similar. Now we are going to find a missing measurement. So in order to do this, we want to set up a proportion, and there's going to be one number missing in that proportion. We'll use that for our variable, and then we will solve. So we're going to do very similar steps to what we were just doing, but one of the side lengths are going to be missing. Now again, be careful because we see X, BC here is what we're missing. Now it does not correspond to this 24. Notice that the shape, the rectangle on the right, it kind of laid down, it rotated. So that short measurement, that X matches up to 8. So be careful when you write these proportions. So we could write X over 8, those are our corresponding side lengths. Now the other set of corresponding side lengths, we have 57 and 24. So we will, again, the X is on top, so that side length, the other side length, 57, also has to go on top. If you accidentally put it on bottom, then it would not be a correct proportion, and we wouldn't get a correct answer in the end. Okay, once we have that proportion set up now we can use cross products. So one of our diagonals is 24 times X. We're going to use that variable. The other one is 8 times 57. Once we do that, then we have a variable, an equation that we can solve for. So 8 times 57 is 456, and then we have 24 times X. So to solve for X, remember we do the opposite, and we're going to divide both sides by 24, and that's how we get X by itself. And then 456 divided by 24 is 19. Everything in this problem was labeled with feet. So that missing measurement up here is 19 feet. Okay, we're gonna do another one. Again, notice your side lengths here. So I'm gonna go straight to my X. The triangles aren't sitting perfectly, so that's the base of the triangle. And then we have the 72 corresponds to the 18. And you could start with either of those corresponding sides. It doesn't matter which one you write first. I am going to do the 12 over X first, and then the second one would be 72 has to go on top since I put the 12 on top in the first ratio, 72 over 18. Then our proportion is set up, so we're going to use our cross products. So one diagonal is 12 times 18. The other one is 72 times X. And notice I put the X first last time. It really doesn't matter which one comes first. So 12 times 18 is 216. And then we want to solve for X. So we want to get rid of the number that is with X. So that 72 we're going to divide by. And in this case, my X is on the right side. 216 divided by 72 is 3, so that side length is 3 centimeters. Okay, now I'm going to have you pause and see if you can do numbers 7 and 8 and set up your proportions correctly and then solve. So I will do those quickly then to see if you're on the right track. X pairs up with 10 and 75 corresponds to 15. So my first ratio, I'm going to do x over 10. Since x is on top, I have to keep that same triangle, the first triangle, 75 on top over 15. Then cross products, so 15 times x is one diagonal, 10 times 75 is the other, and set them equal to each other. So we get 750, and then we will divide by 15 to get x by itself. So 750 divided by 15, we get x is 50 feet. All right, notice we are solving for a measurement, so I'm labeling all of these with the units. And last one, 14 matches up to 17, x matches up to 68, and again, you may not have done them in the perfect order here, and that's okay. There are many different proportions we can create as long as they stay consistent, meaning corresponding sides match up, and then whatever you have on the top, that same shape for the other side length also goes on top. So there's a correct proportion, one of the correct proportions. Multiply cross products, set them equal to each other. 14 times 68 is 952. And then to solve for x, we will divide by 17. So x equals 56 millimeters. I'm going to pause there. I know there's a second page, and we can use that for some extra practice and examples in class if you guys need them. So that is how to determine if two shapes are similar, and then how to find a missing side length in similar shapes.